Hello everyone and welcome. I am Kunal Bandale, Project Associate at IIIT Nagpur. Today I will be presenting an overview of our ANRF pair project titled A Unified, Explainable, Interpretable and Responsible LLM-Leveraged Framework for Detecting EEG-Curated Disorders. This project is being carried out under the guidance of Dr. Tausif Diwan, Dr. Pooja Jain, Dr. Nileshchandra Pikle and Dr. Snehal Shinde. In this seminar, I will briefly introduce the problem we are addressing, explain our proposed framework and share the progress we have made so far. Let's start with the problem statement. Neurological disorders like Alzheimer's disease, epilepsy, and brain stroke affect millions of people and are major health burden worldwide. Detecting them early can save lives and improve treatment. Right now, EEG signals are read manually by doctors. This depends on doctors' experience. So, results can vary from person to person and it does not scale well when there are many patients. Some AI models are being used, but most of them work like a black box. Like they give the prediction but don't explain why, and doctor don't trust them because doctor need a reason. So doctors also can't understand their results. On top of that, EEG data sets are small, imbalanced and hard to collect due to privacy issues. So there is no single system today that can detect multiple brain disorders and explain its decisions in a way that doctors can trust. So, there is where our solution comes in. We are building a unified framework that can detect Alzheimer, epilepsy, and brain stroke all from EEG signals. First, we clean and process the EEG signals, then pass it through deep learning models like transformers, CNN, RNN for accurate classification. Second, we are building a NeuroSage GPT, a medical language model that can fine tune on EEG data. It does not just give the prediction. It explains the result in plain language and can even generate a medical report using RAG to pull in extra medical knowledge. Third, we use explainable AI tools like Sharp, Line, so doctors can see exactly which part of the EEG signal led to the prediction. And finally, since EEG data is limited, we use GANs and diffusion models to generate realistic synthetic EEG data, which also help protect patient privacy. The end goal is to build a cloud-based application that can actually doctor use. So before moving forward, let me show you a small working version of this idea that can interpret how doctors can visualize things. So I have built a STCA-Net model web application. So this is a complete application we have built using Streamlit UI framework. So here on the left side, I have put some dummy patient data, and for now, just for the presentation, I will generate a synthetic data. So you can see that our web application is generating EEG signal graphs, and after the AI analysis result, the result are in three forms. First one is binary detection, then three class classification, and then five class. So the doctor can exactly know what part is getting, why this is getting, and where this complete conclusion comes and how the AI is giving the conclusion. So after just viewing all this stuff, there is a download PDF report option where doctors can actually download the report and check the complete report, and they will know exactly what is going wrong and help them to identify whether it is a seizure or not seizure in epileptics findings. As you just saw in the demo, our STCA-Net model is already trained and deployed for elliptic seizure classification. It achieves nearly 98% accuracy for binary classification and strong results even for 3 class and 5 class classification. The clinical report generation and a web-based screening tool are already working for the doctors. So for the real clinical data, our team visited Shrushruth Pathology Lab in Kolhapur. We collected EEG recordings from over 2000 patients and spoke with the clinical experts about recording protocols and started work on converting their EEG formats into a research ready formats we can use for training our models. So finally, we are looking ahead. We plan to expand our EEG dataset through collaboration with AIIMS Nagpur and TCS, and also standardize all the data into common formats like EDF, CSV, and MET. We will build a complete pipeline for data parsing, cleaning, and pre-processing, and extend our deep learning models to cover more disorders, including sleep disorders and cognitive state analysis, building toward one scalable EEG analysis framework. Thank you for watching. We are excited about the progress so far and looking forward to the next milestone. Thank you.